Hey, we need to add a new image display feature. Oh, I built that 2 years ago. It was clean, it was lean. Honestly, one of my favorite things I've ever written. Great, so you can extend it. Absolutely. I got this. I have a physics degree, and I've spent 20 years in software. And somewhere along the line, I started noticing that the laws that govern the physical world, they keep showing up in our code, in our teams, in the decisions that we make every day. This series is about naming those patterns so we can use them to make better decisions, recognize pitfalls before they happen, and build better software. And today's law, entropy. Entropy is a measure of how much energy in a system is no longer available to do useful work. The simplest way to picture it is degradation. Things getting older, weaker, less capable over time. Take a piece of iron. As time passes, it rusts. It becomes brittle, unreliable, structurally unsound. It used to be capable of doing work. Now it isn't. That is entropy in action. The second law of thermodynamics says that in a closed system, a system left completely alone, sealed off, exchanging nothing with its environment, entropy only goes one way. Things don't randomly oscillate between functional and degraded. They tend toward degradation. A battery discharges. Iron rusts. Organic matter decays. Left alone, systems lose their ability to do useful work. Over time. Always. That's not a choice. That's physics. That's entropy. If entropy always increases in a closed system, then the only way to counter the immediate effects is to open the system. Take rusting metal. You can clean it, treat it, remove the rust. That's external energy coming in and degraded material going out. You spent energy cleaning, scrubbing, removing the rust. That energy wasn't in the system. It was invested from the outside. The system isn't closed anymore, and it isn't degraded anymore. The exchange mitigated the entropy. Locally, you restored function, and that's the trade. Now, quick note. If you watched the last episode, you might be wondering, didn't we say energy is always conserved? How could we suddenly get new energy to appear from the outside? We did say that, and it's still true. When you open a system, you're not injecting energy from nowhere. You're zooming out. The boundary of the system got bigger. Now it includes you, the energy source, the environment. Conservation still holds. The box just expanded. And that's the key insight. Entropy isn't loss. It's degradation of function. And the only way to counter it locally is continuous, purposeful input from outside the local system. Local order, a fresh piece of metal, a functioning system, is a temporary state. One you have to keep paying for. The moment you stop, the default takes over and things degrade. We call it tech debt. And that framing isn't wrong exactly, but it's incomplete. Tech debt implies someone borrowed something and needs to pay it back. It implies a decision was made, probably a shortcut was taken, and now there's a bill due. But that's not the whole picture. Codebases degrade by default, not because of bad decisions, because of decisions, period. Every decision encodes an assumption about the world at the time it was made. Time passes, the world moves, and the assumption doesn't. That's not incompetence, that's entropy. The dependency your team chose 3 years ago was probably the right call. It was well maintained, widely adopted, fit the use case perfectly. Then the ecosystem moved. Newer image formats appeared. Video standards changed. Browser APIs evolved. The dependency didn't keep up. Nobody touched your code, but your code stopped working with the world around it. And this doesn't just happen in code, it also happens in teams. A team that only ever looks inwards, that never brings in outside perspective, never challenges its own assumptions. That team is treating itself as a closed system, and closed systems degrade. The entropy isn't just in code, it's in the thinking. Think about a product your team built and then pivoted away from. Nobody decided it should rot. The code was solid, the architecture was sound, it was genuinely good work. But the team moved on. Investment stopped. And slowly, the ecosystem moved around it. Dependencies aged. New standards emerged. The assumptions baked into the code stopped matching the world outside it. Nobody touched it. That was the problem. That's entropy. And that accumulated gap between what the system needs and what it's receiving, that's what we call tech debt. Not a shortcut someone took, not a decision to borrow against the future. Just entropy, doing what entropy does in a system that stopped receiving external investment. This isn't failure, it's physics. Treating maintenance as optional is treating your code base as a closed system. And by now, we know what happens to those. Any system left to itself degrades. That's not a software problem, that's the second law of thermodynamics. And the response isn't a one-time fix. It's continuous, deliberate investment from outside the system. Maintenance is one expression of that. Team health is another. Dependency hygiene is another. Tech debt isn't a bill that came due because someone cut corners. It's entropy that accumulated because the system wasn't receiving enough external investment to counter it. That reframe matters, because if it's failure, the response is blame. If it's physics, the response is budgeting, explicitly, deliberately in a line item. Not, we'll clean this up when we have time. Time is a mechanism of entropy. Waiting for time is how you lose to it. Now, zoom out to the team. A team that only looks inwards, that never challenges its own assumptions, never brings in outside perspective, is a closed system. Opening the team might mean bringing in new thinking, new approaches. It might mean deliberately revisiting decisions that made sense 3 years ago and asking whether they still do. The team needs external input to stay functional. Without it, the thinking degrades along with the code. Features versus maintenance isn't a trade-off between progress and cleanup. It's a trade-off between short-term output and long-term capacity to do useful work. If you only invest in features, you're building on a degrading foundation. The features ship, the system gets more brittle. Entropy doesn't pause while you're building, it compounds. And investment isn't the opposite of progress, it's the condition for it. Your code base isn't failing, it's rusting. It's doing exactly what any system does when it stops receiving investment from the outside. That's the second law of thermodynamics. And now, you know what to do about it. This is part of an ongoing series, The Physics of Software, where we take the laws that govern the physical world and find them showing up in our code, in our teams, in our decisions. If this resonates, please subscribe. There's more physics where that came from. And if there's a concept from physics you keep seeing show up in your work, drop it in the comments. I'm always looking for the next episode. And remember, physics is awesome, software is human. See you next time.